Howdy everyone, it's your SI Parker. Today we're going to be going over SP7 and a couple problems that you might have had a few issues with. So we're starting on page 117 with question 1. Question 1 says, explain how you can determine the number of x-intercepts a quadratic function will have by knowing its a value and vertex. So I've set up a couple graphs. And we can really have three different cases of where our vertex can be. It can be above the x-axis, on the x-axis, and below the x-axis. All right, so if we have a vertex above the x-axis and it opens up, meaning its a value is greater than 0, we can see that it does not cross this x-axis, so it has no x-intercepts or roots. Right? But if it is above the x-axis and it opens downwards, like this one does, we can see it crosses it twice. So that means we have two x-intercepts. Now, if the vertex is on the x-axis, we can have it open upwards and we can have it open downwards. But we can see it just bounces off the x-axis, and that means that we would have one x-intercept on both of those, right? So now if we have the vertex below the x-axis and it opens up, or a is greater than 0, again we have 1 and 2 x-intercepts. Now if we have a is less than 0, again it's going to be 0 x-intercepts. All right, so now we're going to move down to question number 3. Question number 3 gives us a function of a quadratic function, and it says f of x is equal to 2x squared plus 8x. So we know this opens up because we have a positive a value. Our axis of symmetry, we use negative b over 2a. So when we work that out, we get x is equal to negative 2. So we're going to move over here. X is equal to negative 2. So remember, that is the proper notation for the axis of symmetry because it is a vertical line. So again, x is equal to negative 2. And then our y-intercept. When we have our y-intercept, that's going to be our c value. So this would be like plus 0, right? So again, the proper notation for that one is 0, comma, our y value. But in this case, it is 0, right? So I also have already found the vertex. Remember, we plug in our x value for our axis of symmetry into the original function, and I got it to be negative 8. So all the way down there. So again, this one is negative 2, comma, negative 8, because that's x, comma, y. All right, so number of x-intercepts. Just as we went over up here, if we have our vertex below the x-axis and it opens upwards, we're going to have 2 x-intercepts. And we can find that. So instead of going through and finding our second x-intercepts mathematically, since we have an axis of symmetry, that means we can find our first one, which was pretty easy to find, right? 0, 0, and it's an axis of symmetry, so it's going to be mirrored on the other side. So we have 1, 2 spaces away on the right, so we're going to go 1, 2 spaces away on the left. All right, so those are our 2 x-intercepts, 0, 0, and then this one is negative 4, 0. And now we can graph our function. All right, passes through that point, hits that one, and goes back up. Perfect. All right, so now we have the domain. Remember, domain is going to be all of the x values that our function can be. Well, with a quadratic formula, we can have, or a quadratic function, it can be all of our x values, because this line is going to keep going up and to the left, and then this one is going to be same thing and up and to the right. So our domain is going to be negative infinity, comma, infinity. And I use parentheses because we'll never reach infinity. Remember, you use a bracket whenever we include a point on our graph. So in the range, we know it's all y values, and since we open up, our range is going to go to infinity. Oops. But our lowest value is going to be that -8. And we do include that -8, so it's going to be a bracket, right? So now we're going to move on to question 7. Create a quadratic function with an axis of symmetry of -3 whose graph opens down. So if we want our graph to open down, that's just simple as making our a value negative, so less than 0. Well, the easiest one I can think of is a is equal to -1, right? So now, if we want our axis of symmetry to be 3, well, we have our axis of symmetry equation right here, and it says 3 is equal to our axis of symmetry. Well, we just determined what our a value is going to be, then we have our x. So we have one equation and one unknown. So 3 is equal to -b, because we don't know our b value yet, over 2 times -1. Now we just have to solve for b. Well, if this is on the bottom, we can multiply by 2 times -1 is -2 on both sides. And we're going to come over here, and it's going to be -3, or -2 times 3, which is -6, is equal to, well, these ones are going to cancel out and make 1 is equal to -b. Now we just have our two negatives, so we can divide by -1 on both sides, and then that just means that those negatives are going to go away, right? So our b is equal to 6. So now our last step is to write out our whole quadratic function, right? So we have our a value, so we say a is -1 times x squared plus, we found our b value, 6x, plus, and then we could choose anything for c. I'm just going to choose 0. That's equal to 0, right? Because that's the standard form. If we come over to a Desmos calculator, we can see that if we type in x is equal to 3, that's going to give our quadratic function its axis of symmetry. And then if we put plus 0, boom, you can see that that vertex is on x is equal to 3. If we wanted to choose a different value, we could do plus 4. Well, our vertex is still on x is equal to 3. And that doesn't matter for any of the functions. We can even do negative, so -4. Right? And that just makes our y-intercept different, but our axis of symmetry stays on x is equal to 3.